In this demonstration, we're going to work with two network troubleshooting utilities. First, we're going to look at ping, and then we're going to look at tracert. We're going to practice using these commands on a workstation on subnet A. We're going to use these utilities to work with other hosts on the same subnet, hosts on different subnets within our same organization, and hosts out on the internet. As you can see, there are two routers between my workstation and the internet, one router here and one router here. Any traffic that goes out to the internet from my workstation must go through these two routers. The first thing we want to do is to verify our IP configuration on this workstation. Let's open up a command prompt. We'll use the ipconfig command to do that. We use the /all parameter so we can see all the available information. When we do, we see that the IP address assigned to this workstation is 192.168.0.101, and its subnet mask is 255.255.255.0. That means we're on the 192.168.0.0 subnet, and the default gateway is 192.168.0.1. And if you look here, you can see that our DHCP server has the address 192.168.0.2. We also have a DNS server with IP address of 192.168.0.2, as well as a backup DNS server out there on the internet with an IP address of 8.8.8.8. I'm going to type CLS to clear the screen. The first utility we want to practice working with is the ping utility. The ping utility sends out an ICMP echo request packet to a remote host that you specify. When that host receives the packet, it responds back with an ICMP echo response. If your system receives an ICMP echo response, that tells us two things. First, it tells us that there is physical connectivity between my workstation and the remote host that I'm pinging. And second, it tells me that the protocols are properly configured on that physical infrastructure. So the packets are making it through. Let's try using it. Let's ping a host that's on my same subnet. Let's go ahead and try to ping my DNS server. So let's ping 192.168.0.2. When I do, 4 ICMP echo request packets are sent to 192.168.0.2, and 4 ICMP echo response packets are received in return. Now, there's a lot of good information we can pull from the output of ping. This parameter right here tells us how big the ICMP echo request packet was in bytes. The time parameter over here tells us how long it took from the time that we sent the ICMP echo request to the time that we received the ICMP echo response. As you can see, each one took around a millisecond. Some summary statistics are displayed down here. We sent 4 requests, we received 4 responses. 0 were lost. You will on occasion have instances where you may send 4 requests and get 3 responses back and lose 1. That could be caused by network congestion, bad network cards, and all kinds of different things. So if that happens, you may need to do some troubleshooting. We also have some averages for our round trip time. The response was basically almost instantaneous, 1 millisecond, because we're on the same subnet. Notice up here that we pinged by the IP address of the remote host. You don't have to do that. You can also ping by domain name. So let's try that. Ping corpnet.xyz. Notice that ping first resolves this host name into the associated IP address. Then it sends the same 4 ICMP echo request packets to the remote host. Pinging by IP address first and then by DNS name can be very valuable. The reason is because if you can ping the remote host by IP address but can't ping by its DNS name, it tells you that the basic connectivity is there, the protocols are working. But we may have a problem with our name resolution system. Maybe we have the wrong DNS server address configured, or maybe our DNS server is down. Maybe it doesn't even have a record for the host that we're trying to ping. Let's go ahead and clear the screen. We know everything is working well so far, so let's go ahead and send a ping through this router out onto the internet. We'll type ping, and then we'll type the DNS name of a server out on the internet. It's testout.com. DNS will resolve testout.com into the appropriate IP address. We'll send the 4 ICMP echo request packets. Again, we got all of our responses for each of those packets back, meaning that we have good connectivity out to the internet. Notice that there's something different right here. Our round trip time is much slower. That's because these packets had to go through 2 of our organizational routers. Then they went out onto the internet and went through many different routers, probably 8 or more, before they finally reached the destination host. The ping packets had to travel such a long distance that the round trip time was considerably longer. We can see that down here in the summary statistics. At this point, let's shift gears and look at the tracert utility. Ping is awesome for testing connectivity between 2 hosts, but it doesn't reveal much about the path a packet has to take through various networks between the sending host and the destination host. If you need to troubleshoot routing problems, then you need to use the tracert command. Now be aware that on Windows, this command is spelled tracert, and on Linux systems, it's traceroute. Also, be aware that the way tracert works is a little different on Linux and Windows. On Windows, it uses the ICMP protocol, just like ping. On Linux, it uses the UTP protocol instead of ICMP. Tracert is interesting. It uses the same ICMP echo request packets as ping. However, it manipulates that ICMP echo request packet a little bit to reveal the IP address of each router between the source sending system and the destination system. It does that by manipulating the time to live parameter, the TTL. We don't want packets circling the internet endlessly because they couldn't reach their destination host. The ICMP protocol is designed so that every time a packet has to cross a router, the router will automatically subtract the value of the TTL by 1. If this number gets down to 0, we can pretty much assume that the packet is going nowhere. Instead of letting it circle the network endlessly, we just drop it. So let's test this out. We'll just do a tracert between this system right here and my default gateway right here. First, we'll do this with the IP address. They're on the same subnet, so we really shouldn't see a whole lot happening here. Now let's do a tracert using our domain name. Let's do tracert-corpnet.xyz. As you can see, we got 1 hop right here. We see the DNS name and IP address of this first hop router. So now let's do something a little more complex. I'm going to clear my screen by typing CLS. Now let's do a traceroute to www.testout.com. This is going to require a little bit of time to complete because we're going to send packets to a host out on the internet. It'll have to hop through several different routers before it finally reaches the destination system. Now we're seeing many hops delivered by the tracert command. You'll notice right here, we have the same first hop that we looked at before. Now it continues going through routers or hops to the destination device. Each router it goes through is called a hop. Sometimes you'll see a message from one of the routers that says request timed out. This usually means that the router is configured not to respond to ICMP echo requests in order to prevent denial of service attacks. Traffic is going through it just fine. It's just ignoring all the ICMP traffic that's sent to it. You can see that in order to get to testout.com, a packet has to move through 5 different routers. Okay, so there are 5 hops between my system and testout.com, with this last IP address being the end device. Normally, you don't count the last device as a hop since it's not actually a router in most cases. With this information, you can troubleshoot problems if you're not able to reach hosts out on the internet. For example, if this router right here were down, the second hop, then we would see no output for the rest of the routes all the way down because none of the packets were making it past this router. That can help us say, oh, okay, I know where to start troubleshooting because I know that this router is working just fine. The problem is with this guy right here. Okay, that's it for this demonstration. In this demo, we practiced 2 very useful troubleshooting tools. First, we looked at ping, and then we looked at tracert.